Hello everyone, my name Muhammad Nabil bin Muhammad Rafi. I am from Wushu team. I would like to introduce to you guys my group member. First is me, Muhammad Nabil bin Muhammad Rafi. The second one is Muhammad Nazmi bin Nawawi. The third one is Muhammad Afdzal bin Muhammad Bakhri. And the fourth one is Muhammad Farhan bin Muhammad Rushdi. Before we start, I would like to inviting you guys to watch my video that I provide to understand a little bit about the modulation.
Do you think that you can throw a piece of paper to a distance of 5 to 10 meters? It is impossible because the paper is of less weight. At the same time, if you enclose a stone inside the paper, it can reach longer distance when it is thrown. This is because of the stone's weight. Stone carries the paper along with it. Here,
Okay, now I will explain about what is actually modulation. Modulation is a signal transformation to a format suitable for transmission through a chosen medium. Actually, the paper is actually indicate the modulating signal. The stone is the carrier signal. When we are combining these two, we are creating the modulated signal. So that's how we are want to transmit the signal. Okay, now, so I will explain what is amplitude modulation and how it's work. So, what is amplitude modulation? Actually, it is a change in amplitude of the carrier according to the modulating signal, while the frequency of the carrier signal remain unchanged. From the figure here, we can see this one is a modulating signal and the second one is the carrier signal. When we are combining these two, we will create the amplitude modulation signal. So now, this is the type of amplitude modulation. First, we have here is double sideband suppressed carrier, DSBSC. This one actually we are eliminating the carrier. So the second example is the double sideband full carrier. This signal have the carrier in the middle. And the third one is single sideband suppressed carrier, SSBSC. We are eliminating the carrier and also the lower sideband. Okay, so the last one is what is the difference of bit rate and baud rate? Okay, so bit rate is actually a number of bit transmits per second, and baud rate is actually a number of symbols transmitted per second. So that's all from me. Thank you.
Part 2, angle modulation. Angle modulation is when frequency or phase of the carrier is varied by modulation signal. So we go to see the basic concept of angle modulation. This angle of sinusoidal signal. So the formula of angle of sinusoidal signal is theta t equal to omega c t plus omega naught. So the four non-linear process of the theta t equal to theta xt. So we know the gradient represents instantaneous angle frequency for the sinusoidal signal. So uh, we get the can calculate the instantaneous angular frequency omega I at the time t by calculating the gradient of graph theta t at the time at the disk, and the instantaneous angle value is given by integration of theta t integration of omega I t dt. So we go to the next is amplitude and frequency modulation. In right side, we can see the finger amplitude and frequency modulation. We can see the different each carry signal amplitude modulation wave and frequency modulate wave. So amplitude modulation is an a modulation technique used in electronics communication, most commonly for the transmitting message with a radio wave. This technique contrasts with angle modulation, in which either the frequency of the carrier wave is varied, as in frequency modulation, or it phase, as in the phase modulation. So the advantage of modulation sickness is first, noise immunity. Most noise cause amplitude variation in modulate wave. In frequency modulation and phase modulation, limiter are used to remove amplitude variation. So the second is the noise perform and the signal to noise improvement. Noise reduction by limiter improve SNR ration. Lastly, capture effect. If two signals are retrieved with a same frequency, the receiver will capture the stronger signal and the weaker signal is eliminates. So we go to the part disadvantage of this modulation sickness. The advantage of the modulation sickness is firstly bandwidth. Bandwidth frequency modulation take up more spectrum space compared to amplitude modulation. Modulation and demodulation circuit required for the frequency modulation and phase modulation are usually far more compact than those of the amplitude modulation. So the application in daily life of the modulation signal is the first radio broadcasting, second two-way mobile radio, third microwave communication, next we can see satellite communication, TV sound transmission.
Hi, I will explain about phase shift changing (PSK). Phase shift changing (PSK) is a digital modulation process which conveys data by changing the phase of a constant frequency different signal. PSK have two types. First, the binary phase shift changing (BPSK), and second, quadrature phase shift changing (QPSK). Binary phase shift changing (BPSK). The modulation of BPSK is by multiplying two signals, carrier signal and binary data. This is carrier signal and this is binary data. The output is PSK wave. Output BPSK modulated wave will invert 180 degree when the input binary sequence changes their state. As you can see from the example, when the input binary sequence changes from state 1 to state 0, the output wave will invert 180 degree. Next, we move to quadrature phase shift changing (QPSK). QPSK is a form of phase shift changing in which two bits are modulated at once. Selecting one of four possible carrier phase shift, QPSK allows the signal to carry twice as much information as ordinary PSK using the same bandwidth. Represent four different symbols by combination of two bits, that is 00, 01, 10, and 11. The phase change from 45 degree, 135 degree, 225 degree to 315 degree. For change in phase was represented two binary bit data per symbol. So there is four symbols. This is binary bit data. That is 00, 01, 10, and 11. This is phase per symbol. The carrier was sent to four phase which is 45 degree, 135 degree, 225 degree, and 315 degrees. So for the first symbol that is 00, the phase is 45 degree. For the 01, the phase was 135 degree. For the 11, the phase was 225 degree. And that's why for the 10, the phase was 315 degree. Next, we move to quadrature amplitude modulation (QAM). QAM is a modulation method in which two signals are used to amplitude modulate two carriers that are quadrature 90 degrees out of phase with each other. So the yellow one is the example of quadrature signal that is 90 degree from the signal. Sixty change in phase can be represented for binary bit per symbol. As you can see, this is 16 symbol and each symbol have four represent binary data. Okay, thank you.
Advantage of radio digital modulation. First, efficient use of spectrum space. Second, increased amount of information that can be passed down a single channel. Lastly, improves audio clarity at low receiver signal level approaching sensitivity. So we go to the disadvantage of radio digital modulation. Firstly, it requires more bandwidth as compared to an analog system. Second, more expensive to fit when it goes wrong. Lastly, it needs synchronization in synchronous modulation. So we go to the last part is application in daily life of digital modulation. First, we can see is CDMA, code division multiple access cellular service. Second, wireless local loop. Next, Iridium is a voice data satellite system. Lastly, DBS digital